In this video, we're going to look at everything that you need to know for Cambridge A's Level Mathematics 9709, Probability and Statistics 1, Probability. Let's start with basic probability. To find the probability of any event, we divide the number of elements in an event by the total number of elements. So we can say the probability of A is equal to the total number of outcomes in A divided by the total overall number of outcomes. Let's look at an example. There are 6 beads in a bag. 3 are red, 2 are yellow, and 1 is blue. What is the probability of picking a yellow bead? So we can say the probability of yellow is equal to, there are 2 yellow beads out of a total of 6. Let's simplify our fraction and we get 1 over 3. The complement is the probability that an event does not happen. When working with the complement, the sum of the probability and its complement will always be equal to 1. So to find the complement, we simply say 1 minus the probability that something does occur. Now let's look at the probability of one event or another. When looking for the probability of one event or another, we add the two probabilities together. Here we have the probability of A, B, with a symbol between them that looks like a U. We call this union. When you see union, we are looking at one event or another. Let's look at an example. A fair single 6-sided dice is rolled. What is the probability of rolling a 2 or a 5? When you have a fair dice or a fair coin, you know that there is equal probability of rolling any side. Here our dice is 6-sided and there is 1, 2. So the probability of rolling a 2 has to be 1 over 6. There is 1, 5. So the probability of rolling a 5 is also 1 over 6. To find the probability of rolling a 2 or a 5, we add these together. So we can say 1 over 6 plus 1 over 6, which gives us a probability of 2 over 6. Let's do another example. A glass jar contains 1 red, 3 green, 2 blue, and 4 yellow marbles. If a single marble is chosen at random from the jar, what is the probability that it is yellow or green? Let's start with the total number of marbles in the jar. 1 plus 3 is 4, plus 2 is 6, plus 4 is 10. So my sample space, total number of outcomes, is 10. I have 3 green marbles and 4 yellow ones. 3 plus 4 gives me 7. So probability of a green marble or a yellow marble has to be 7 out of 10. Now we can move on to the probability of one event and another. When looking for this probability, we multiply our probabilities together. Here we have the probability of A and B. This symbol means intersection. One way to look at it is that our symbol could be the top of a capital A. So when you see the symbol, it is the probability of one event and another. Let's look at an example. An unbiased coin is flipped at the same time that a fair dice is rolled. Find the probability of obtaining a head and a 5. When a coin is unbiased, there is equal probability of it landing on heads or tails. So, for the coin, the probability of a head has to be 1 over 2. We have a fair dice, 6-sided. There is 1, 5. So the probability of the dice landing on 5 has to be 1 over 6. When considering one event and another, we multiply our probabilities together. So I can say the probability of a head and a 5 is equal to 1 over 2 multiplied by 1 over 6, which gives me 1 over 12. Now I'd like to move on to independent and dependent events. Events are independent if one event does not affect the second. To prove that events are independent, you need to prove that the probability of A and B is equal to the probability of A multiplied by the probability of B. Let's look at an example of independent events. A bag contains 5 green beads and 4 red beads. A bead is taken from the bag, its color noted, and is then replaced. A second bead is then taken from the bag. What is the probability that 2 beads are different colors? The first thing we need to note is that the first bead is replaced in the bag, so it does not affect the outcome of the second bead. The question asks us about the probability that the 2 beads are different colors. We have green beads and we have red beads, but we could draw a green bead first and a red bead second, or we could draw a red bead first and a green bead second, and we need to account for both of these situations. In the bag, we have 5 green beads. I'm going to make a note of this up here. 5 are green, 4 are red. 5 plus 4 is 9. So we have a total of 9 beads. With these values, we can now find the probability. We have 5 green beads out of a total of 9. So I have 5 over 9 for my green bead and a red bead. So we multiply the red beads, 4 over 9. Or we could have a red bead first. When we have one event or another, we need to add. We have 4 red beads out of a total of 9. So probability of a red bead first, 4 out of 9. And so we multiply a green bead second, 5 over 9. Now I can put all of this straight into my calculator. So I can say 5 over 9 multiplied by 4 over 9 plus 4 over 9 multiplied by 5 over 9 is equal to 40 over 81. This is the probability that the 2 beads are different colors. Now let's look at dependent events. 2 events are dependent if the outcome of the first affects the outcome of the second. In your exam, look for keywords such as without replacement. This tells you that the first event affects the second. Let's look at an example. A drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and is not replaced. Another paper clip is taken from the drawer. What is the probability the first paper clip is red and the second paper clip is blue? Here I have a red paper clip first and a blue paper clip second. Red and blue. So we need to multiply these together. I have 3 red paper clips and 5 blue paper clips. 3 plus 5 is 8, plus 4 gives me a total of 12. Let's start with the red paperclip. I have 3 red out of a total of 12, so I can say 3 over 12 multiplied by. The paperclip is not replaced. So once the red paperclip is removed, I now have 11 left. This is my new total. So I still have all 5 blue paper clips. I can say 5 out of the total of 11. Take my calculator. I can say 3 over 12 multiplied by 5 over 11 is equal to 5 over 44. This is my answer. Now I want to move on to conditional probability. Conditional probability describes the probability of an event occurring given that a previous event has already occurred. If you see the word given, then you're working with conditional probability. In conditional probability, we use the following equation. This line over here means given. So we are saying the probability of B, given that A has occurred, is equal to the probability of A and B divided by the probability of A. Let's look at an example. A maths teacher gave her class 2 tests. 40% of the class passed the first test and 60% of the class passed the second test. Find the probability that a student passed the second test given they passed the first test. The word given tells us that we are working with conditional probability. So the best place to start is to create our formula. So I can say the probability of the second test given the first test was passed is equal to the probability the first and the second test was passed over. In the denominator, we use the given probability, the first test, the probability of the first test. The question tells us that 42% of the class passed their first test. So you can say the probability the first test was passed. Let's make this a decimal and we get 0.42. We also need the probability the first and the second tests were passed. So I can say the probability of first and second is equal to probability of the first test, 0.42, and the second test, we're going to multiply. The second test was passed at a rate of 60%. Make it a decimal, we get 0.6. Now I can take my calculator, 0.42 multiplied by 0.6 is equal to 0.252, and I can leave it like this for now. Now that I have the probability of the first test and the first and second test, I can put these values into my formula. So I can say 0.252 over the first test, 0.42, say 0.252 divided by 0.42 is equal to 0.6. This is our conditional probability. In your exam, you may need to draw a tree diagram. Tree diagrams allow us to represent probabilities in a visual way. Make sure to allow enough space for all of your branches. Use your allocated page. Please don't try and squeeze your tree into a small corner. You will be marked down if your examiner can't see what you're trying to say. To make it easier, divide your page vertically for every event. And remember that the sum of the probabilities on every pair or group of branches will always be equal to 1. Let's look at an example. Sajid is practicing for a long jump competition. He counts any jump that is longer than 6 meters as a success. On any day, the probability that he has success with his first jump is 0.2. For any subsequent jump, the probability of a success is 0.3. If the previous jump was a success, and 0.1 otherwise, Sajid makes 3 jumps. Part A says draw a tree diagram to illustrate this information, showing all of the probabilities. So let's make some space. We are considering 3 jumps, so let's divide our page into 3 and make sure to label your 3 jumps. So we can have jump 1, jump 2, and jump 3. For every jump, it could be a success or a failure. So for jump 1, we need 2 branches. Then for jump 2, 2 branches from there, and 2 branches each for jump 3. Now we can remove our vertical lines. For every jump, Sajid could have a success or a failure. So for jump 1, could be a success or a failure. For jump 2 and for jump 3. Now that we have a general outline of our diagram, let's see what information the question has given us. The question tells us that on any day, the probability of a success on his first jump is 0,2. So let's start there. Let's go to our diagram. The probability of a success on jump 1 has to be 0,2. Remember that any pair of branches are complementary. They add up to 1. So if a success is 0,2, the probability of a failure has to be 0,8. Now we can go back to our question. It also tells us that for any subsequent jump, the probability of a success is 0,3 if the previous jump was a success. Otherwise, it is 0,1. So, if Sajid has a successful jump on his first one, the probability that his second jump is successful has to be 0,3, which means the probability that his third jump is successful is also 0,3. Any pair of branches are complementary. 1 minus 0,3 gives us 0,7, which means the probability of failure is 0,7 and 0,7 over here as well. The question also tells us that if Sajid fails his first jump, the probability of a success on his next jump is only 0,1. So if Sajid fails jump 1, the probability that the second jump is success has to be 0,1. These events are complementary, which means the probability of failing his second jump has to be 0,9. If he fails his second jump, the probability that he succeeds in his third jump, again 0,1, which means the probability of failure 0,9. Now we can look at jump 3. If he succeeds on his second jump, the probability he succeeds on his next jump has to be 0,3, which means the probability of failure is 0,7. But if he fails on his second jump, the probability he succeeds on his next jump is only 0,1, which means the probability of failure has to be 0,9. And now we filled in our tree diagram. Part B says find the probability that Sajid has exactly one success, given that he has at least one success. The word given shows us we are working with conditional probability. So let's start by creating our equation. You can say probability that Sajid has exactly one success. So let's say of one success, given that he has at least one success. So at least one success is equal to the probability of one success and at least one success all over the probability of at least one success. Let's start by finding the probability of at least one success. Let's say at least one success. Now, if someone has at least one success, Sajid could have one success, he could have two successes, or he could have three successes. There are numerous combinations of successes that he could possibly have. The only thing that Sajid can't have in this case is three failures. Because if he has at least one success, he cannot have all three failed jumps. So to find the probability of at least one success, we can say 1 minus the probability of three failures. To find the probability that all three jumps were a failure, let's look at our tree diagram. If he fails the first jump, 0,8, the second jump, 0,9, the third jump, 0,9. We have a failure and a failure and a failure. So for three failures, we multiply the probabilities together. We can say 1 minus the probability the first jump was a failure, 0,8, multiplied by the second jump being a failure, 0,9, multiplied by the third jump being a failure. Now I can say 1 minus, let's take my calculator, 0,8 multiplied by 0,9 multiplied by 0,9 again, 0,648. 0,648. Let's subtract this value from 1. So 1 minus my answer is equal to 0,352. 0,352. This is the probability of at least one success. But for conditional probability, I also need to consider the probability of exactly one success and at least one success. So let's make some space. If I have exactly one success, I only have one success. If I have at least one success, I can have one success, two successes, or three successes. Here we want the probability of at least one success and exactly one success. So out of these three options, this is the only one that I can choose. So I need to find the probability that Sajid had only one success. To have one success, he can succeed on his first jump, or his second, or his third. This means that if he succeeds on one jump, he fails on the other two. So if he succeeds on his first jump, he fails the second and the third. If he succeeds on the second jump, he must fail the first and fail the third. If he succeeds on his third jump, he fails his first, fails his second, but succeeds on his third. We can find the relevant probabilities in our tree diagram. Let's start with Sajid succeeds on his first jump. So his first jump is a success, but his second one is a failure, and his third one is a failure. He has one successful jump and a failure and a failure. So we need to multiply these values together. So I can say for the successful jump, 0,2 multiplied by the first failure, 0,7 multiplied by the second failure, 0,9. Now I can take my calculator, 0,2 multiplied by 0,7 multiplied by 0,9 is equal to 0,126. So I can make a note of this over here, 0,126. Now let's find the probability that the second jump was a success. If the second jump was a success, that means the first jump was a failure, the second was a success, but the third one was also a failure. And again, we multiply these probabilities together. So I can say 0,8 multiplied by 0,1 multiplied by 0,7. Take my calculator, 0,8 multiplied by 0,1 multiplied by 0,7 is equal to 0,056. 0,056. Finally, let's find the probability that the third jump was a success. If the third jump was a success, that means the first jump was a failure, the second jump was a failure, but the third jump was a success. So let's multiply these probabilities together. I have 0,8 multiplied by 0,9 multiplied by 0,1. Take my calculator, 0,8 multiplied by 0,9 multiplied by 0,1 is equal to 0,072. But remember that if Sajid has one success, he could succeed on the first jump, or the second, or the third, which means we need to add these probabilities together. I already have 0,072. I'm going to add 0,126 and 0,056 is equal to 0,254. Let's say 0,254. This is the probability of one success. Now that I have these values, I can put them into my formula for conditional probability. So I can say the probability of one success and at least one, 0,254, over the probability of at least one success, 0,352, 0,352. Take my calculator, 0,254 divided by 0,352 is equal to 0,7215. Let's round off to 3 decimal places, and I get 0,722. Now we can move on to part C. On another day, Sajid makes 6 jumps. Find the probability that only his first 3 jumps are successes, or only his last 3 jumps are successes. If he only has 3 successful jumps out of a total of 6, if the first 3 are successes, that means he has successful jumps for the first 3, and the second 3 have to be failures. If the last 3 jumps are successes, that means the first 3 are failures, and the second 3 are successes. You can use your tree diagram to find the respective probabilities. Let's start with the scenario where the first 3 jumps are successful. The first jump successful has probability of 0,2, then 0,3, and 0,3 again. So let's start there. We have one jump and another. So we can say 0,2 multiplied by 0,3 multiplied by 0,3 again. The next 3 jumps are failures, but this jump over here, it's the 4th jump. So we need to consider the probability of a failure after a success. And from the tree diagram, we can see that this will be 0,7. If he fails again, 0,9. He fails again, another 0,9. So we can multiply this by 0,7, 0,9, and 0,9 again. I'm going to leave this as it is for now, and let's look at our other scenario. In the second scenario, his first 3 jumps are failures. So on our tree diagram, the first jump is a failure, the second jump is a failure, and the third jump is a failure. So we need to multiply these probabilities together. So we can say 0,8 multiplied by 0,9 multiplied by 0,9 again. His 4th jump is a success, but remember that this jump is after a jump that was a failure. So to find the probability, we can start with a failure and then success. So if the fourth jump is successful, probability is 0.1. The fifth jump, 0.3. And the sixth jump will be 0.3 as well. So now we can multiply these. 0.1 multiplied by 0.3 multiplied by 0.3. Now you can multiply these out individually and then add them together, but you will get very long decimals. So it's easier to put all of this into your calculator. Just remember that Sajid could have the first 3 jumps being successful or the last 3 jumps, which means we need to add these probabilities together. So I'm going to take my calculator. For the probability that the first 3 jumps were successful, I can say 0.2 multiplied by 0.3 multiplied by 0.3 again, multiplied by 0.7 multiplied by 0.9 and again 0.9. And now we're adding the probability that the third 3 jumps were successful. 0.8 multiplied by 0.9 multiplied by 0.9 multiplied by 0.1 multiplied by 0.3 multiplied by 0.3 is equal to 0.016038. This is our final answer, 0.016038.